Assalamualaikum and good morning. I be to Dr. Hasina and my fellow friends. So I will explain about group 14 binary compound, which is oxides. So basically, oxide is any chemical compound that contain one or more oxygen atom. So the first one is germanium. The properties of germanium oxide is it has a tetrahedral 4 coordinate GeO4 unit structure. It also exists in a 6 coordinate crystalline form like rutile-like structure. The physical properties of germanium oxide is white powder, and germanium oxide also has a basic properties. So germanium oxide can be produced by burning germanium metal in air. Germanium oxide are used as optical material and as a catalyst. Next is tin. First one is tin oxide. Tin oxide has a red and black form and is soluble in water. It has a tetragonal crystal structure. So next is tin dioxide. This oxide has a yellowish or light grey powder and has a rutile crystal structure. This oxide is soluble in water. Both of these oxides has unfortunate properties. Next is the synthesis and the uses of the tin oxides. So the first one is tin oxide or SNO. Tin oxide can be produced by controlled heating of tin to in the absence of air under a CO2 atmosphere. It can be used as opacifier and pigment carrier and as a precursor and reducing agent. Next is tin dioxide. Tin dioxide can be produced by burning tin metal in air. Tin oxide also used in section of combustible gas and used as a polishing powder. So next is lead. So the first one is lead oxide. There are two types of lead oxide, which is litharge and massicots. Litharge have a tetragonal crystal structure and massicot have a orthorhombic crystal structure. Next is lead tetraoxides. This solid has a bright red or orange color and has a tetragonal crystal structure at room temperature. Last is lead dioxide. It has dark brown solid which is soluble in water and hexagonal crystal structure. All of these oxides are unfortunate properties. Next is synthesis and use. So the first one is lead plumbum oxide. Plumbum oxide can be produced by heating lead metal in air at approximately 600 degrees Celsius. So the uses of lead oxide is as the component of the cathode of lead acid battery. So next is lead tetraoxide can be prepared by oxidative annealing of white lead. And this oxide used as pigment for primer paint for iron object and curing agent. Next is plumbum tetraoxide. This oxide can be prepared by oxidative annealing of white lead. This oxide can be used as pigment for primer paint iron object. So last is lead dioxide. Lead dioxide can be produced by the reaction of lead tetraoxide with the nitric acid, and this oxide can be used as construction of high voltage lightning arrestor and the cathode of lead acid batteries. That's all from me. Thank you.
Hey Internet, welcome back to Chaos Chem. Right now I am doing a very simple experiment here, and I am going to make some lead-2 oxide, or I am making some lead-2 oxide. And what you're seeing here is I have my gas burner set up with my clay pipes supporting a little crucible, and inside the crucible I have added some lead nitrate. And so what we do is we just let this go, and we will start to see it turn a yellow orangish color. And once all of this has decomposed into the yellow orange color, we have obtained our target product of lead oxide. So let's let this react, and I will come back and show you what it looks like when it is all done. Okay, so it took about 15 minutes, and our white lead nitrate has converted into what you see there. That is lead-2 oxide. And so this is pretty much ready for use.
So next, I am Muhammad Arif Amirul. I'll be explaining about the simple compound of silicon and oxygen. Reaction between oxygen and silicon create a compound called silicon dioxide, also known as silica, with the chemical symbol of SiO2. It is a colorless crystal found mainly as quartz, sand, and flints. As for its chemical properties, it is not a very reactive compound due to the polarity of the molecule is zero. It forms a two double bond with the oxygen, thus making it a very stable molecule, and has a high dielectric strength, making it a good insulator. Moving on to the physical properties, the compound have a melting and boiling point of 1600 degrees and 2230 degrees respectively. For its solubility, it is insoluble in water and acid except for hydrofluoric acid. For its synthesis process, solid silicon react with oxygen gas, producing silicon dioxide with a temperature of 1900 degrees Celsius. Lastly, silica is used in toothpaste as tooth plaque, anti-caking agent, and also pharmaceutical tablet.
Assalamualaikum and good morning. My name is Fahmi Izzuddin bin Cik Samsudin, and I will present about the compound with nitrogen. The binary compound of the group 14 with nitrogen is cyanogen. Secondly is silicon nitride, and lastly germanium nitride. We will go for the first of the binary compound, which is cyanogen. Cyanogen C2N2, also known as a pseudo-halogen, and this is because it have a similarity with the halogen group. Then we will go to the synthesis of the cyanogen. It can be prepared by the oxidation of the hydrogen cyanide. 2 mole of the hydrogen cyanide will react with the nitrogen dioxide and will produce cyanogen, nitric oxide, and water. And then we will go to the chemical and physical property of the cyanogen. Firstly, cyanogen is a very toxic gas. Secondly, it is a colorless gas. It is soluble in water. It can boil at the negative 21 Celsius. It is flammable, and it can dissociate to give a CN radical and form interpositional halogen compound such as cyanogen fluoride and cyanogen chloride. And then we will go to the uses of the cyanogen. Cyanogen also used as a fuel gas for the welding and cutting metal. Secondly, as a rocket propellant. Third, as a fumigant. Fumigant is a compound that is used as a pesticide. And lastly, it can use as a organic synthesis. Then we will go to the next. The general formula for the silicon nitride is Si3N4. We will go to the synthesis of the silicon nitride. Silicon nitride can be produced by direct reaction of silicon and nitrogen gas at high temperature. 3 mole of silicon will react with 2 mole of nitrogen gas and will produce silicon nitride. And the second synthesis of the silicon nitride is by carbothermal reduction of silicon dioxide in nitrogen atmosphere at 1400 until 1450 Celsius. Then we will go to the chemical and physical property of the silicon nitride. Silicon nitride is very hard and inert. Secondly, the melting point is 1900 Celsius. Third, it has a low density. It is insoluble in water. And lastly, it has a good oxidation resistance. Then we will go to the uses of the silicon nitride. Firstly, it is used as a automobile industry as a material for the engine part. Secondly, as a orthopedic application, metalworking and cutting tools, and as a insulator and chemical barrier in manufacturing integrated circuit. The general formula for the germanium nitride is GE3N4. Germanium nitride can be produced by the direct reaction between Ge and ammonia at a high temperature. 3 mol of germanium will react with 4 mol of ammonia and produce germanium nitride and 6 mol of hydrogen gas. And then we will go to the physical and chemical properties of germanium hydride. Firstly, it is have a crystalline solid appearance. The boiling point is 900 Celsius. It is colorless and it is inert solid that crystallize in many polymorph, of which the most stable is the trigonal beta form. And the germanium nitride can use as a ceramic manufacture and also as a semiconductor. That's all for my part, and we will continue about the carbide and silicide. Thank you.
Silicon nitride appears to have a lot of the qualities that you would want for clinical success.
It is strong, it is wear resistant.
High strength, high reliability, wear resistance.
We see good bony ingrowth. Patients feel very good. The surgeries went smooth, the healing went smooth.
It is stronger than any ceramic that we've ever used in orthopedics.
It has the advantages of surface chemistry, the ability to have bone attached to it, and a similar chemistry and an atomic number to bone.
Silicon nitride is widely recognized for its exceptional strength in key NASA shuttle components, jet engines, and body armor. Because it's made from elements already in the human body, scientists believe it would make a more compatible human implant material than peak polymer or metal. Several of the world's top ceramists spent years proving this theory. Today, their efforts have paid off.
It's binary compound of carbon with an element that less electronegative than carbon. There are 3 types of carbide, such as silane carbide, metallic carbide, and metallic carbide. Silane carbide are formed by carbon with an element of group 1 alkali metal, group 2 alkali earth metal, or by aluminum. Metallic carbide are the combination of carbon with d-block elements. D-block elements also known as traditional elements. Metallic carbide is formed by carbon with boron and silicon. Silane carbide, also known as ionic carbide because of due to the ionic bond. Barium carbide and aluminum carbide is example of carbide that contain carbide ion. For example, when aluminum carbide react with water, it will produce aluminum hydroxide plus methane. This carbon ion derived from methyl. Calcium carbide, CaC2, and sodium carbide, natrium carbide contain the dicarbon ion that derive from acetylene. In reaction in the slide, we can see when calcium carbide react with water, it will produce acetylene and calcium hydroxide. And when calcium carbide react with gas nitrogen, it will produce calcium cinamide that be used for fertilizer. Next is graphite integration. It's formed by alkali metal wafer with carbon by redox process with cutting tools. Iron carbide Fe3C as a major component of steel. Metallic carbide, also known as covalent carbide. The 2 types of metal carbide is silicon carbide and also boron carbide. When silicon oxide react with 2 carbon, it will give silicon carbide and carbon dioxide in electric furnace. When boron oxide react with 4 carbon, it will give boron carbide and 3 molecules of carbon dioxide. These properties are hard covalent solid, high metal point, and chemically inert. Silicide is a binary compound of silicon with an element that is more electropositive than silicon. There are 3 types of silicide. First is alkaline metal silicide, second is alkaline earth metal silicide, and third is transition metal silicide. For alkaline metal silicide, they are salt like silicate due to ionic bond. Silent, but silent is a covalent bond. Lithium silicide LiSi used as anode of lithium-ion batteries. Sodium silicide reacts with water, appears as black gray crystalline powder, and potassium silicide. Second is alkaline earth metal silicide. Salt silicide, magnesium silicide is a crystalline solid used as a semiconductor and in photo-optic application. Calcium silicide, strontium silicide, and barium silicide is example of alkaline earth metal silicide. Lastly is transition metal silicide, general formula MnSi and MsIn. M represent of metal of element of transition metal. Thin film of metal silicide are used on circuit of semiconductor and microelectronic device. Good electric conductivity, high chemical inertness, and thermal stability. Reaction of silicide. Magnesium silicide react with acid hydrochloride. We produce silane and 2 magnesium chloride. How to form magnesium silicide? When 2 Mg heating by silicon, we form magnesium silicide. Next, we are going to talk about alkali metal silicide, where sodium silicide react with water, it will produce sodium metal silicate and 3 hydrogen gas, 3 molecules of hydrogen gas. How to form sodium silicide? 2 natrium react with silicon will give natrium silicide. Lastly, there are 3 types to produce titanium silicide. First is directly metallurgy reaction, will involve titanium and silicon. Secondly, involve a sputter test with titanium tetrachloride react with silane, we produce titanium silicide. And lastly, when titanium tetrachloride react with 3 silicon, we give titanium silicide.